Hello and welcome. So why are you taking this course? You're taking this course because the future of computing is here and you have a role to play. Quantum computers will solve some of the tough problems beyond the reach of classical computers, a milestone known as quantum advantage. In the next few minutes, we're going to look at some of the applications of quantum computing and the road ahead. The integration of quantum computing, AI and classical computing into hybrid multi-cloud workflows will drive the most significant computing revolution in 60 years. Quantum-powered workflows will radically reshape how enterprises work. So before we go a little more deeper into quantum computing, we need to know that quantum technologies actually include quantum cryptography, quantum communications, quantum systems, and quantum hardware, among other things. But the focus of this course is going to be on quantum computing. And today we are going to focus more on the application aspects of it. So quantum computing actually incorporates science, mathematics, engineering, business, programming. It's a truly multidisciplinary area where students from diverse branches can actually take this course on quantum computing. So whether you're from physics, chemistry, computer science, or engineering, you actually have a role to play in this. And industry is excited because the compelling applications in finance, materials, chemistry, logistics. So there are several of these, right? And so this is an area that spans multiple disciplines and can potentially impact several industries. You're going to see a lot of collaboration among people from different backgrounds as we start to make impact in this field. So there are several potential use cases of quantum computing that industry and academia have started exploring. And this slide, lists out some of these. And you'll see that these are very interesting use cases, things that, even the most powerful supercomputers today are not able to perform to a very good extent, right? And that's what makes it a very exciting set of potential use cases for quantum computers. So for example, IBM and Daimler are working towards using quantum computers to model material systems, including lithium sulfur, that are relevant to advancing the performance of batteries, right? So this is one very interesting use case. Here is another one. Quantum computers are also being used in the financial services industry to model the expected value of financial instruments. They can be used for some of the compelling banking issues in India, like modeling non-performing assets, loan risk profiling, and many such applications. Quantum computers are being looked at as the next generation tool for chemists and chemical engineers developing advanced energy solutions. Several industries are actually exploring quantum applications. These range from, automotive, finance, logistics, healthcare, and this is a list of, applications, and a lot of, research papers have also been published, and there are links on this page that take you to some of those research papers so that you can go deeper into these applications. So in this course, you will learn to write quantum programs in Qiskit and run them on actual quantum hardware systems of today. So you'll write some of this in Qiskit. The textbook is available online. Qiskit also provides libraries for you to write models in machine learning, chemistry, nature, finance, and optimization. In this course, you will learn how to write quantum circuits to take on the role of a kernel developer. You'll also look at some of the quantum algorithms and learn how you could write them yourselves. Finally, you'll also learn to develop models for real-world use cases, like the ones we briefly discussed in areas like chemistry and finance. The rapidly growing quantum industry will require quantum aware and quantum proficient engineers. And this course is going to look at how you can do some of these roles. So the quantum era is coming and you need to be ready. Quantum is expected to have a big impact on businesses. Businesses are going to need people with quantum skills, and already several companies are hiring quantum engineers and scientists. But adding quantum to existing workflows, we are expected to see drastic improvement in our problem solving capabilities. As Nobel laureate Bill Phillips said, using quantum principles to compute is as different from classical computing as a classical supercomputer is from an abacus.